So good morning all. In today class we are going to discuss about strategies of flow testing. Strategies of flow testing. So data flow testing strategies or structural strategies. So data flow testing strategies are based on selecting test path segments that satisfy some characteristics of data flows for all the objects. Here you are going to take one data object is nothing but it's a variable. So for that you are going to satisfy all the paths. Just wait. In contrast to the path testing strategies, so data flow strategies take into account what happens to the data object on the links in addition to the raw connectivity of the graph. So path testing, so along with that path testing, in each path, each link, you are going to define what happened to the data object. So for example, if I define a variable a, if I define a variable a, so for that you are going to draw one path testing. So path test. Now in this path testing you are going to specify what happened to this variable a, data object a. You can specify that. Okay, so data flow testing strategies are based on selecting test path segments that satisfy some characteristic of data flows for all the data objects. In other words, data flow strategies require data flow link weights. So this is the different weights here. So D, K, U, C, and P. So D means define. So D means define. K means kill. K means kill. U means use. U is nothing but using the data object. C means computing. C is nothing but computing. Computing. P means predicate. P means predicate. Okay, so that means data flow strategies required data flow link weights. So that means, for example, this is the data flow for data object A. Now you can specify the D, the C, like that. So D means define, C means compute, so U means usage, and K means kill. You can specify like this. Okay, so data flow testing strategies are based on selecting test path segments that satisfy just wait. Data flow testing strategies are based on selecting test path segments that satisfy some characteristic of data flows for all data objects. In contrast to the path testing strategies, data flow strategies take into account what happens to the objects on the links in addition to the raw connectivity of the graph. In other words, data flow strategies require data flow link weights DKUCP. So this is the example diagram, the example for data flow testing. Now we see one control flow graph. Just wait. So now we see one control flow graph. So let us, these are the nodes. And this is the path. So this is the path. Okay, so this is the begin. So this is the begin. So node 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the end. 8 is the end. So this is the control flow graph. Okay, so this we are taking as a example. So begin. So this is the 2, 3, 4. So 5, 6, 7, 8. Okay. So in this we have terminology. The first one is so definition clear path setting. What is the first one? So definition is a clear path segment. So definition is a clear path segment. A path segment is a sequence of connected links between nodes. A segment path is nothing but a path segment is a sequence of connected links between nodes. The first link of the path is defined and the subsequent links of that path is killed. So the path 1, 2 here, if you see that, so the path, so 1, 2, 1, 2 and 3, 4, 5, 6 are so definition clear. So why? So after completion of this one, you are going to execute this second. So that means the path 1, 2, 3, 4, 5, 6 are clear. The path 7, 2, 3, 4, 5, 6. Just wait. The path 7, 2, 3, 4, 5, 6. Okay. So is not so definition clear because the variable is defined. So 2, 3, 4, 5 and again 6, 7. Okay, so coming to so clear path segment, a path segment is a sequence of connected links between nodes. The first link of the path is defined and the subsequent links of the path is killed. The path 1, 2 and 3, 4 and 5, 6 are so definition clear. The path 7, 2, 3, 4, so 5, 6 is not so definition clear. So because the variable is defined on so 2, 3, 4, 5 and again 6, 7. Okay, so another terminology is so loop free path segment. Just wait. So loop free path segment. Another one is loop free path segment. In path which does not have any loop, in path which does not have any loop and every node of which is visited at most one is known as loop free path segments. In path 2, 3, 4, 5, sorry, so 2, 3, 4, 5, 6 are loop free, but the path 6, 7, 2, 3, 4, 5, 6, 7 is not, because the node 6 and 7 are visited twice and hence so form a loop in that path. Okay, so loop free path segment is nothing but the path which does not have any loop and every node of which is visited at most once. If the node is visited only one time, then we know that as a loop free path segment. The path 2, 3, 4, 5, 6. The path 2, 3, 4, 5, 6. So 2, 3, 4, 5, 6 are loop free, but path 6, so here 6, 7, 2, 3, 4, 5, 6, 7 is not. So because the node 6, 7 are revisited here. So you take this path 2, 3, 4, 5, 6. In this path, we visit all the nodes only one time. Okay. If you take this path 6, 7, 2, 3, 4, so 5, 6, 7. So it is not, because it is not loop free. Why? Because these 6 and 7 are visited twice and hence from a loop in that path. Okay, so this is the terminologies. So definition: clear path segment. So loop free path segment. A path segment is sequence of connected links between nodes. The first link of the path is defined and the subsequent links of that path is killed. For example, so 1, 2, 3, 4, 5, 6. Okay, the path 7, 2, 3, 4, 5, 6 is not definition clear because the variable is defined. So 2, 3, 4, 5 and 6, 7 and again on 6, 7. Okay, another one is loop free path segment. So that means if you visit the node at only one time, that we are called as a loop free path segment. If you visit the node more than one time, then they are not loop free path segments. Okay, and coming to strategies. So data flow strategies, the structural test strategies discussed now. So we are going to discuss all these on the program control flow graph. You're taking the flow graph, same flow graph. Okay, the coming to first one, all du path. What's the first one? All du path. So what is the d here? D means define. So d means define. U means used. That means the data objects are defined and used. A du path is a path which has a defined variable and has a computational use as a predicate use of that variable. Okay, coming to definition, all du path strategy is a data flow testing strategy that requires every definition of every variable from every du path. So that means here the du path is a path which has been defined variable and has a computational use as a predicate use of that variable. So okay, so that we are called, that strategy we are called as a all du paths. ADUP, say means all, so D means define, U means use, P means paths. So ADUP, all du paths. So coming to second one. Okay, we see one example for this. So this is the node 1, 2, 3, 4. So this is the flow graph annotated for variables A and B. So variable A and B. Okay. So this is the begin. So this is the end. So A, D here. So B. Now, so variable A and B are used on the data flow link 1, 3. So 1, 3. Any test that starts from the link 1, 3. So 1, 3 satisfies this criteria. So that means all du path strategy. So only for variables A and B, but not for all the variables here. Okay, this is the flow graph for variables A and B. That means A and B are so used on the data flow link 1, 3. So this is the one A is the on 3 link B. Okay. And next one, all uses AU strategy. So next one, so all uses AU strategy. So all uses strategy helps in reducing the number of test cases. All user strategy is a data flow testing strategy that requires every definition from at least one path segment to use every variable that can be reached by that definition. So that means the same example here, similar example. So this is the begin 2, 3, 4, 5. So this is the first node, second, third, so fourth and fifth one. So this is the begin and this is the end. So this is the A. Here, so all uses AU strategy. So all uses AU strategy is a data flow testing strategy that requires every definition from at least one path segment to use every variable that can be reached by that definition. Here, so this is the flow chart for a variable X. A variable X. If a variable X has a predicate used in ADUP strategy. So ADUP means, so this is the ADUP strategy. That means, so all, so define and use path strategy. The subpath 2, 3, 4. If you observe, this is the subpath. 2, 3, 4 is the subpath. Actual path is 1, 2, 3, 4, 5 or 1, 2, 4, 5. Okay, in this, so 1, 2, 3, 2, 3, 4 and 2, 4. So this is the 2, 3, 4 or you can pass as a 2, 4. The path is a 2, 4. Either 2, 3, 4 or 2, 4 can be included in some test. In AU strategy, either 2, 3, 4 or 2, 4 can be included, but we don't have to use both to begin a path. So that means the link, so 2, 3, 4. That means when you are testing the data flow for this variable X, you can include the path, so 2, 3, 4 and as well as so 2, 4. Okay, so that means we don't have to use both to begin a path. The link 2, 3, 4 can be included in some test cases because that the only to reach the C. So that means the C. So for example, this is the C computational. So C is nothing but computation here. That means if here this you think that this is the predicate. If it is true, we enter into this block. If it is false, we reach the fourth one. Then in that cases, we can ignore this computation. So why? If it is true, then only we take this path. Otherwise, the path will be 2 and 4. So that we are called as a all uses AU strategy. All uses AU means U means uses strategy is a data flow testing strategy. Here C is computational that we can ignore. So next one, third one, all P uses or some C uses. All P uses or some C uses strategy. Okay. P means predicate. What is the P? P means predicate. Predicate. Similarly, C means compute. C means compute. If a variable has a predicate use, then there is no need to select a computational use. Okay, if there is a predicate, then there is no need to select a computational use. We see the example. So this is the one, begin, 2, 3, 4, 5, 6, 7, 8, 9. So define. So this is the predicate P. CD. So computational undefined. CD. So computation undefined. CD. So computation undefined. This is P predicate. So this is the predicate and 9. This is the end. So this is the example for flow chart for, so flow graph for, so variable Z. Let us assume. Okay, if a variable has a predicate use, then there is no need to select a computational use. In APU plus C strategy, every definition of every variable has a path, every predicate use of that definitions. If there is no P use of definition, then a C use is considered. In this figure, so 1, 2, 3, 4, 4, 5, 5, 6. So must be included in test cases because they contain definition for variable Z here, CD. So in 2, 3, predicate and 6, 1, 2, so definition. So 2, 3 is a predicate and 3, 4 you are going to define, and 4, 5 so you are going to compute and define, and 5, 6 also compute and define. So you must be include in test cases because they contain definition for variable Z. The links 2, 3, 6, 7 and 8, 9 so must be included in test cases because they can predicate uses of Z. In these, so 2, 3 and 6, 7 and 8, 9 must be included in test cases because they contain the predicate use of Z. In this testing strategy, the definition of variables are not covered, then additional computation will be to cover the definition. Okay, that is the purpose of all P uses or some C uses. So APU plus C strategy. That means the predicate uses or some computational uses. So next one, all C uses or some P uses. That means all computational uses or some predicate uses strategy. Okay, in this testing strategy, so first ensure that every definition has a computational use of that definition, has a computational use of that definition. Okay, just wait. So AC plus ACU plus P is a strategy that require every definition of every variable included at least once. Okay, we see one diagram for this. So 1, 2, so 3, 4, 5, 6, 7, 8, 9, 10. So these are the nodes. So define. So this is also a flow graph for Z. C means computation here. So 3 to 4, so compute. So 4 to 5, predicate P, and 5 to 6, predicate P. So predicate is nothing but here the variable is used as predicate. So 4 to 7, so compute. So 7 to 8, compute, and say 8 to 9, and this is the end. So 10. So this is the begin, and this is the end. So ACU plus P coverage is achieved for Y. So here the variable is Y by path 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So next one, so all definitions strategy. So all definition strategy is nothing but AD. So AD strategy is weaker than both ACU plus P and APU plus C strategies. So all definitions means D means so definitions. So this strategy is weaker than both ACU plus P and APU plus C strategy. So AD is a strategy that requires every definition of every variable to cover at least one use of that variable. The use can be a so computational use C or a predicate use P. And sixth one, so all predicate uses strategy. In this testing strategy, so every definition of every variable has a path to every P use of that definition. So we see one more time, all predicate uses strategy. In this strategy, so every definition of every variable has a path to every predicate use of that definition. So APU is the testing strategy that requires a P use of definition if there are no C use following that definition. So last one, all computational uses strategy. So this we are called as ACU strategy. So ACU is a testing strategy that requires a C use of definition. So all computational uses ACU strategy. So ACU is a testing strategy that requires a C use of definition if there are not P use following. So that means it follows the strategy that it requires the C use of definition if there are the P use. So that we are called as all computations. ACU is nothing but all computationals and uses. If it is CU, so that means there we can compute that and you are going to use that. For example, say A equals to say A plus 1 or A plus plus. Here we are going to compute and you are going to use that value. So okay, so all computational. So coming to the definition of the strategy, so ACU strategy should be so weaker than ACU plus P and APU plus C strategies. Okay, so STM is very theory subject. So when you are so doing your lab, then you can understand these topics very well actually. Okay, this is the end of the class. In tomorrow class, we are going to discuss about slicing and dicing in Dataflow. Thank you all. So we meet in tomorrow class.